Hi, in this video we are going to talk about Fibonacci numbers in the main, so let's get started. The Fibonacci sequence is the following: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34 and so on. So we just have to add the two previous number in order to get the given number we are looking for. So the Fibonacci numbers are defined by the recurrence relation Fn is equal to the Fn minus 1 plus Fn minus 2. So the previous two item defines exactly the given item we are looking for. And of course the 0 item is 0 and the first item is equal to 1. By the way, we generate our functions, we can get a closed form. This is the so-called Binet formula. And with the help of Binet formula, it is very, very easy to compute without recurrence and recursion. Okay, so what is the problem with the recursive formula? And the recursive formula is this Fn equal to Fn minus 1 plus Fn minus 2. The problem is that we calculate same problems over and over again. So for example, if you want to calculate the fourth Fibonacci number, and if we see that the fourth Fibonacci number is equal to 2, by the way, then we come to the conclusion that we have to know the third Fibonacci number, F3, and the F2, because this is a recursive formula. And recursive formula has a tendency that if you want to know the n item, we have to know the n-1 and the n-2 item. But in order to know the F3 and the F2, we have to know the F2 and F1 for the F3, and we have to know the F1 and the F0. Then for the F2, we have to know the F1 and the F0. So we come to the conclusion that this is the so-called overlapping subproblems. We calculate F2 two times, even for very, very small Fibonacci numbers. And you may guess that if it's a huge, for example, we would like to get F99, the 99th Fibonacci number, there would be lots of overlapping subproblems. And we have been talking that, okay, the solution is we have to use dynamic programming. If we have overlapping subproblems, then we definitely use dynamic programming and memorization in order to avoid recalculating a subproblem over and over again, because that's what's happening here. We calculate F2 two times instead of just one. How can we solve this problem? With the help of memorization. In Java, we should use a hash map data structure to store the solution for the subproblems. And it's very important. I'm not sure whether you are familiar with time complexities for data structures, but hash map has a constant time complexity when we want to insert and when we want to get items from it. So it's very, very efficient. It's very fast. So in every method call, when we call this F method, when the F, of course, is the recursive formula for the Fibonacci sequence, we insert the calculated value if necessary. So we check whether if we have this value in the map, we take it from the map without recalculating it. And if there is no entry in the map, we calculate it and insert it in order to avoid recalculation in the future. And why is it good? Because instead of the exponential time complexity, we will have a linear time complexity. And a linear time complexity algorithm is very good. Of course, on the other hand, it requires ordo n space complexity. And it's quite common in algorithms that if we want to speed up an algorithm, we would end up using some space. If we want to reduce the space complexity, then our algorithm will be slower. So it's like a balance. But this is why it is very good to use dynamic programming. Instead of the exponential time complexity, we will end up linear time complexity, which is very, very good. So in the next video, we are going to implement it together. Thanks for watching.